A very good evening, everyone, and welcome to the chemistry class. So, what we were doing in the last class, have started the very first chapter of the 12th class, that is the haloalkanes. If you people have just looked into the NCERT, then you get to know that we have started the very first reaction mechanism, which is known as the electrophilic aromatic substitution reaction, right? Okay. So Shillong is there, St. Paul Center, and Aswal. Okay, Aswal is there. And so I hope you people have started, reading the chapter from the NCERT. And you people, because why in every class I used to say that particularly for the organic chemistry is very important to revise all the concepts. It's very important to revise all of the topics because the things are interlinked. And if you just miss the last episode, then you will not be able to correlate with the further story ahead. Okay, so let's start what we were doing. I am writing the very first mechanism. We have started the organic chemistry, and from that we have started the electrophilic. I have already told you that what is an electrophile, what is the nucleophile, right? So, electrophilic aromatic substitution reaction. And I have told you that in the short form we used to call it as the ESR reaction. Okay. Do you people remember the reaction? How many of you remember? Yes, Aswal Center is there. Electron loving. Obviously, we know that electrophile is electron loving. So, we have written the mechanism also in the last class. Do you people remember it? See, I am just writing for the sake of the revision. This is a benzene. You know that 6 pi electron density is there in the benzene. And let's say we have a electrophile, then what will happen? You know that you replace one, I'm just making it like this type of benzene. So remove one hydrogen and just place the electrophile there, okay? Remove one hydrogen and you can just place the electrophile there. Is it clear? If I write the mechanism as well, what was the mechanism, everyone? What we used to do, see, these are the pi bonds and I know that if I have the electrophile, what will happen now? This electrophile will go and attack over the pi bonded system of the benzene. This will go and attack over the pi bonded system of the benzene. How will it look like? You know that when a bond breaks, at one side we get the positive charge, at the other side we get the negative charge. So obviously the electrophile go and attack over the negative charge, right? See, if this is the negative charge place, it there. At the other side of the carbon, I will be getting the positive. And in the next step, what will happen? What we used to do? This is the bond with the carbon and hydrogen. Just remove this bond, okay? You just remove the H plus. What you will get? See, the aromaticity will regain. Oh, very nice. Senapati Center, you are there. You were not there in the earlier classes, Senapati Center. Okay. So everyone just have a look on the screen. If anybody having any doubt, please let me know. Just have a look on the screen. I have written a mechanism. Senapati Center, you can also check. What we are doing, electrophile is going and attacking over the benzene. We are breaking the one pi bond of the benzene. Okay, I know that electrophile wants the negative charge, so it will get attached over the negative charge species. And I will be getting a positive charge on the carbon. Now this center one, this is my intermediate, okay? This is what? This is my intermediate. CC4 is also there. Now this is my carbocation, okay? Or I can say the name is arhenium ion. This is nothing but arhenium ion. Those who have started the organic chemistry in their school, they might be able to relate it well. But this is the very simple and a very easy mechanism. Everyone just write it down here on the screen if you people have any kind of doubt. If you don't have any doubt, then also please let me know. I am waiting for your replies here. Shillong, are you there? Shillong Center, St. Paul, Aizwal, Senapati Center, and Sisipur. Anyone having any doubt in the reaction which is written on the screen? We have, in the last class, we have started from this reaction, right? Okay, no doubt to Aizwal, very good. Sisipur, Shillong, and St. Paul. St. Paul? Okay. Okay, so nice. So this is clear to everyone, right? And have we started the first reaction of the halogenation? I have told you in the last class also, right, that this is the two-step reaction. This is the two-step reaction. We all know that. Okay, it's a two-step reaction. Which step is the slow step? The first step or the second step? Which step is the slow step? Tell me. Internet is very, very bad. Oh, Sercon Center is also there. Second, St. Paul. Why? I'm saying which step will be the slow step. Oh, no worries, Sercon, it's okay. First step will be the slow step, right? See, listen to me, St. Paul. What will happen? We see electrophile is going over the benzene. So, benzene, what will the benzene say? Benzene says, see, I am stable in my world. I am an aromatic compound. If you want to have some reaction with me, this is the condition, okay? That in the end, like in the product, my aromaticity should be regained, right? So, obviously, the first step will be the slow step. Because in the first step, the aromaticity of the benzene is going away, right? So, I will be writing here, this is a slow step, okay? So, remember it. Shillong, I guess I am able to see you all. Can you people raise your hands? The student from the Shillong Center. Can you raise your hand? Okay, nice. Thank you. Actually, today my screen is so much far away, okay? So very small faces of yours are visible there. Okay, fine. At least you people are visible, right? Okay, now. So the first step is we can write here, that the first step, I am writing it here, the first step is the slow step. And the first step, it means like always the slow step is the rate determining step, okay? Because the other one is already fast, okay? It is more willing to be happen over there, like I'm talking about the second step, okay? So can I write the first step is a slow step, also known as, which is also known as RDS. You understand RDS? It is not RDX, okay? We are not talking about the bombs here. RDS is rate determining step. Rate determining. Just tell me if the RDS is clear to everyone or not. Look at the screen, what I am telling you now, you are getting confused with the first step, right? Those who are still getting confused, I am repeating again because it's important thing, right? So we cannot miss it. Now, Sircon, just look at the screen. This is a benzene, right? Benzene has the 6 pi electron density, okay, because 3 are the bonds. So can I write here that 6 pi electron density is there. So benzene is electron rich now, okay. And my electrophile, it wants electron, it will go and attack over here. Now look at the screen, what will happen? See what will happen if I want to break this bond, say center, what will you see? These two bonds are as it is. If I want to break this bond, what should I write here? I should write at one side positive, at the other side negative, right? This is the way how we break a bond. Break a bond, at one side you will get a positive charge, at the other side you will get a negative charge. Now, if the electrophile is there to attack, now you tell me, Sircon, at which side the electrophile will go? Obviously, the electrophile will go towards the negative charge, right? Now, what will I see here? That these are the two bonds, and here what will happen? There will be then electrophile at the negative charge, and here what I get? This is the carbocation which I get. This is the intermediate which I get. Now in the next step, what is happening, Sircon center? You are removing this bond. Carbon and hydrogen is there. See, everywhere there is the hydrogen. Now we know the formula of the benzene is C6H6. Okay, everywhere there is the hydrogen. So I am saying now this time we are breaking this CH bond here. Okay, if I am breaking the CH bond, how will that benzene look like? Look at the screen. These are the pi bonded system already having positive charge, electrophile is attached. Now if I am breaking the CH bond, H plus is gone away, okay, and here I will get the negative. Are you getting me, Sircon center? Now what will happen? This plus and minus now again make a bond, okay. So it will like this one. The aromaticity is again back. We are having the electrophile instead of the hydrogen. Just tell me everyone now if it is okay. Okay, very nice, very fine, very good. So you got how to do the electrophilic substitution in the benzene ring, okay. Now let's talk about the types. I'm going to write here the types of electrophilic substitution reaction. All of these reactions are there in the NCERT, so this is very important. Types of electrophilic substitution reaction. Everyone, number one, we are writing halogenation. Do you understand halogenation? Now what will happen? Halogen will go and attack over the benzene. Okay, can you tell me which will be the electrophile in the case of halogenation? It means that instead of that E plus which I was writing now, I have to write any halogen. Let's say chlorine I can write, like Cl plus can go and attack, like bromine plus can go and attack, okay? Yes, obviously. So what will happen? Now look at the screen everyone. Now the journal reaction is, okay, I am just writing a journal reaction first of all I am writing the reaction, that this is the benzene, and like what will be written in the questions? You will see like Cl2 in the presence of AlCl3 will be written. So if any halogen in the presence of AlCl3 or ZnCl2 or FeCl3 is written, so what will you do? You will do the chlorination of the benzene ring, right? Now tell me, what do you understand by AlCl3? What is AlCl3 here? Any idea, anyone? Shillong, any idea? St. Paul, any idea you have? Sircon center, obviously, if I am writing AlCl3, it's obviously the aluminum chloride, right? What are you doing? They are just writing the name here. So smart people you are. It's a catalyst, okay? It is a catalyst. What do you understand by the term catalyst? Tell me. Do you know what is a catalyst? Anyone, what do you understand by catalyst? What is a catalyst? What is the function of the catalyst? Speeding up the reaction, okay? Increasing the speed of reaction, okay? Basically, yes, I can say that catalyst is that type of, compound which only deals with the rate of reaction. Do you know that? And actually, you people are writing only the speeding up. They can also decrease the rate of reaction, okay? So you can just think of that catalyst is something which deals with the rate of reaction. They can, although most of the catalysts we use, those increase the speed of the reaction. Because, we want to reaction to get speed up, to get it fast, okay? So they only deal with the rate of the reaction. And one more thing, the part of the catalyst, you will not be able to see any part of the catalyst in the product. Catalyst goes into the reaction, perform its work and automatically comes out, okay? So you can think like that. A very good example I used to give to the students is, like, you people are sitting over there, okay, 1 year is ahead, you people are now reactants, okay, you understand that? So you are having a reaction, you want to convert into the product. Now what is your product? When you will get the very good marks in your board exams, when you get admitted into the very, very good colleges, you will get the good ranks, then that will be your product, okay? Now you people are reactant, and this 1 year is there, okay? So this 1 year, what is that 1 year? This is your mechanism, okay? You understand the term mechanism? Actually, the journey of the reaction is known as the mechanism, okay? So like you are having the 1 complete year ahead. Now you people are reactant, you will get converted into the product once you get the very good ranks, okay? And what we people are doing? We people are the catalyst, obviously. We are trying to speed up your reaction, okay? So we are just trying to speed up your reaction, and we will go into the reaction, we will just take part, and we will come out as it is, okay? So this is a kind of thing, you people can remember. See, we can relate everything with the chemistry. Chemistry is such a beautiful subject. I hope so that you people also consider it as a beautiful subject, and you can relate everything with the chemistry, okay? And what happened is, like, whenever we talk, you have seen it in the movies also. People used to call it like that these two people are having the very good chemistry, okay? Like many dance shows and reality shows used to say that your chemistry was very good, okay? Why don't they say that your maths was very good? Why don't they say that your physics was very good? Because chemistry is actually the study of interactions, okay? So as much as more interactions you are having, this is the way which you are dealing with the chemistry, okay? Okay, then let's coming back to the halogenation. This is the reaction mechanism. Yes, Ercon is writing chemistry is about linking. Exactly it is, okay? And you can just deal with the chemistry in every aspect. Like in the day-to-day life examples, you see a lot of reaction around yourself. And so every time we are, we are participating in every kind of chemical reaction, right? Okay, let's come back. We are in the halogenation process. So Cl2 is there. And AlCl3 is there. Oh, very nice, Saint Paul. Thank you so much. Now, can we have a look on the mechanism? Now, this is the reaction which is mentioned on the screen. Now, we have a benzene there. Cl2, AlCl3 is there. And we are getting a chlorobenzene here, right? Now, if I ask you the question, this is the complete reaction which is there. Now, if I ask you the question, that which will be the electrophile in our case, what will you say? Oh, elegant as chemistry. I just read your comment now. I am happy, St. Paul, that you people like chemistry. Now tell me, if I ask you the question, like I am asking you the question, Which is the electrophile in this question? Chlorine is the electrophile, or what you can say, Silicon center, that Cl plus is the electrophile, okay? Because that positive charge species should be there. Look at the screen I'm writing. And we will form the Cl plus also. See, let's say I have a reaction with Cl2 plus AlCl3. See what will happen here. Cl having the bond like this type, and I have a AlCl3. Now you know that what is AlCl3? AlCl3 is also a Lewis acid. It is a Lewis acid. It wants electron, okay? So see, if AlCl3 wants electron, this is Cl2 is a non-polar type of compound, okay? Cl are having a one single bond, no electronegativity difference is there, but in the presence of AlCl3, what will happen? See, in the presence of AlCl3, what will happen? This will attract the electrons of this bond, okay, generating some delta negative charge, because AlCl3 wants the electron, and this will have a delta positive. You understand the delta? It's a partial positive. It means when the AlCl3 come, it wants electron, it will pull one chlorine towards itself, okay, generating the negative charge over it, and the other chlorine will have the positive charge over it. So when they get completely dissociate, we will get chlorine plus and AlCl4 minus. Everyone just tell me if this step is clear. This is the electrophile which we have generated with the help of AlCl3, okay? Now, once you get the electrophile, the rest of the next reaction is same. Is it clear to everyone? Now, if I ask you to perform the next step, okay, so what will you do? We got the Cl plus. Now just write the same way, the same mechanism is. You people can write it by your own also. The same which we have done, right? It will go and attack here. Then we will able to generate this type of compound. And in the same way, we will remove the H plus ion. So what will happen now? Our aromaticity of the ring will get regained. And everyone, just look at the screen again. See, we are having the H plus. As I have told you, that catalysts do not, shown in the, will not be, it will participate in the reaction. But, the constituent of the catalyst are not visible, or they will not be shown in the product. So what will happen now? This H will take the Cl, like I can make HCl here, at the same time AlCl3 is there. This is the complete reaction, everyone. This is the mechanism which we have written for a halogenation reaction. In the very first step, you have created the electrophile. In the second step, you are, attacking it on the benzene. Just tell me if it is clear or not. Okay, very nice. Clear to St. Paul. Shillong Center, is it clear to you people? Senapati, it's clear. Okay, CC-Pur. Sercon Center, I guess your keyboard system is stuck. Why produce that HCl and AlCl3? Yes, very good question. Sercon, what will happen, if I don't write this thing, what else I am getting here in the product side? I will be getting a H plus ion. I have this thing also with me, that AlCl4 negative. Now what will happen? Just have the reaction. We want the catalyst back. Now what they get, we know that, we are having all of these things are actually in the ionic form, okay? So generally we used to write it as the HCl. When they get, interlinked, we used to write it as HCl plus AlCl3, okay? So this is the way you have to write it down. Are you getting me? I'm saying we don't write the H plus in the, in the ionic form. We used to make the products. We write HCl and the AlCl3. Good. So this question is clear. Can you people just do some of the examples? Directly write down, okay? Directly write down. Let's say I have Br2 in the presence of AlCl3. You know, we used to write FeCl3 or Fe also. The same reaction takes place. Tell me the answers. Don't need to write the complete mechanism again. No need to write. Only write down the products. That's it. Quickly tell me the products. I'm waiting. It's an easy question. Do tell me the major products, okay? Just the major. I am not talking about the HCl or AlCl3, nothing. Like in the previous question that we have done with the mechanism, the answer was the chlorobenzene. In the same way, just tell me the answers of these examples. AlCl3, BrCl3, bromobenzene are the product, and in the next one FeCl. Okay, yes, Ercon, like you people are writing the side products also, no need for that. Just tell me the answers of the main products here. In the exam they are only concerned with the main product. And we can simply do it. It's the Br, and here I can write it will be only the chloro. Okay, so chlorobenzene and bromobenzene. Anyone, any doubt? I'm saying you can take Fe also, or you can write FeCl3 also. Okay, these are all can be used in the place of I can say AlCl3, and you can write this down. Okay, you can just write this down and make it as a note. AlCl3, SnCl2, FeCl3, or ZnCl2, all can be used as catalyst. Okay, everyone? And you can write one more thing. See, I have taken majorly the two examples of the chlorination and bromination. Just keep one thing in your mind, that fluorination, we don't prefer fluorination with this method. Okay, like we cannot easily make the fluorobenzenes by this method. Why? Because fluorination, it's very difficult first of all to break the bond of fluorine. You know that. Okay. Plus one more thing is there, like it is a very explosive reaction. Okay, fluorination is very explosive. If you want to make a fluorine like fluorobenzene at your home, then might be there are the chances that there will be fire everywhere. Okay, so it's a very explosive reaction. That is why we don't prefer it. One more thing, iodination is also not considered a very good method for this one. Okay, why? Because it is a very slow reaction. Okay, it takes a lot of time, and sometimes it is also written that it's a reversible reaction. Okay, so you can write that fluorination and iodination is not preferred is generally not preferred, okay, because fluorination is an explosive reaction and iodination is reversible. Iodination, sorry. Just write it down and tell me if you have any doubt. Done, everyone? So I hope we are done with the first type of reaction. This is the halogenation reaction, okay? Like I have taken here the example of chlorine. You people can take the example of bromination also and any of the example, okay? And let's do one more question. This is like these things, like the simple type of question, like these type of question they can ask you in the board exam, okay? The simple type of questions they can ask you in the board exam. But if somebody say me to set the paper, obviously I will give you this type of question then. Let's say this is the benzene, ICl is given, or I can write, no, BrCl and AlCl3. Tell me the product. Think about it, take your time and just tell me the answer. And I will give you the 4 options also. Bromobenzene, chlorobenzene, bromochlorobenzene, or none of these. Tell me the answer. What is the answer? Sercon Center said it's bromobenzene. St. Paul, Shillong, Sisipur, what is the answer? Now you know what, many people they get confused. They ask me the question that ma'am you have given Br and chlorine. So and one thing is I don't understand that why people used to say that they always say ma'am when the Br and Cl will break they will get Br minus and Cl minus. Because this is somewhere embedded in our mind that a halogen is always negative charge. Don't think like that, okay? If I want to break the bond here, what will happen this time? Okay, see, I have a Br, I have chlorine, okay? If I want to break the bond, I know that more electronegative is chlorine, so it will take the electron towards itself. Again, the same thing that with the LCl3, it will form the bond. So ultimately, I will get Br plus as the electrophile. Once I get the electrophile, I know the rest of the part, okay? So what is the answer in this case? It's a bromobenzene, okay? You got it? Everyone? The bromobenzene will be the answer. Anyone having still doubt, you can ask me. I hope this is clear. Now let's talk about the second type of the reaction, which is known as nitration. First of all, you people will tell me, if I am writing nitration, which group should be present on the benzene? What do you understand by the term nitration? Aswal center, it's very simple. Aswal center, look at the screen. What we are doing now, this is BrCl, bromine and Cl have the bond, okay? What happened? See, this is the Br and Cl, I'm just saying, it's a very same thing, just look at the screen. Like here I have taken the example of the Cl. Now this time, can I take the example of Br and Cl? Now what will happen? If I am taking the example of Br and Cl, then what will happen? Don't you think the same thing will happen again? So, what will I get? Ultimately, what will I get? If I just, have this thing happen, this bond will get break. So instead of the Br plus, instead of the Cl plus, I will get here the Br plus only. Are you getting it, Aswal center? I'm saying it's a very same thing. Like if I have a chlorine, I can have the BrCl as well, okay? So if I have the BrCl, now, they can make a bond with AlCl3, okay? Okay, I am explaining it again, don't worry. I'm saying that, why AlCl3 only attaching with the chlorine? Because chlorine is more electronegative. It will pull the electron density towards itself. So it will look like this, having delta minus, delta plus. Down the group electron negativity decreases Aswal center, okay? That is why this is happening. So once you get it, you will get a Br plus and you will get an AlCl4 minus. Once you get the electrophile, I am saying the rest of the things are known. Because chlorine is more electronegative, it will pull the electron towards itself. It will keep the negative charge over itself. This is what I am saying. St. Paul, what is your doubt? Okay, when we add NO2, okay, you are giving me the answer. Thank you. I thought this is number 2 and I was not, understanding what is the number 2 you are saying. Aswal, I hope this is clear now. Now we are talking about the nitration, everyone. In the nitration, what will happen? Let me write the reaction first. We have a benzene now and we will be having concentrated HNO3 plus concentrated H2SO4, okay? Both acids you will be taking. When both of the acids are there, what I will be getting? I will have NO2 on the benzene. Now if I ask you the question that what is the electrophile in that case? You will say, ma'am, it will be NO2 plus, okay? Because that is the group which I am having on the benzene in the product. Just keep this thing in your mind that HNO3 and H2SO4 both will be used here. Why both we are using, let me tell you. I'll give you the example. And you people will tell me that in HNO3 and H2SO4, which is the stronger acid? Tell me. In HNO3 and in the H2SO4, which is the stronger acid? Very good, Aswal Center. Senapati Center, what is your answer? And CC-Pur, you can also reply. I will be happy. Ma'am, why hydrogen is eliminated during chlorination? Oh, after a very long time, we have a very wonderful center here. Naharlagan is there. Where were you, Naharlagan? I was missing you people. Hydrogen is eliminated. See, this is the actual mechanism, look at the screen. In every step, because the name itself is the substitution reaction. This is the name. So which group you will be substituting? It's the hydrogen. See, here we are removing the hydrogen here, Naharlagan. This is the CH bond. You are removing this CH bond here, okay? So when this hydrogen will go away, only then we will be able to keep that pi bond in order to have the aromaticity back. Are you getting it, Naharlagan Center? I am saying this is the proper mechanism of every electrophilic substitution. It doesn't matter that chlorination you are talking about, or let's say bromination, or let's say nitration. Whatever is the electrophile, when it goes and attack over the ring, you have to remove the hydrogen, okay? Because if you do not remove the hydrogen, you will be getting only this type of compound which is actually not stable. So hydrogen is willing to go away in order to have the aromaticity back. Now is it clear, Naharlagan? Tell me. I hope this is clear now, Naharlagan Center. I'm waiting for your reply, okay? And regarding this one, see, H2SO4 is stronger acid. First of all, I'm writing H2SO4 is stronger acid. Then HNO3, okay? And how the double bond is created again after H is eliminated. See, I have told you, na. Okay. Naharlagan, I guess you people were not there. Once again, I am telling you to everyone. I am again writing all the things again. Quickly, okay? Just try to understand it very quickly. Naharlagan, please pay attention. This was the benzene, right? This was the benzene. We have an electrophile, okay? So electrophile wants to go and attack over the ring. Now look at here on this system here, Naharlagan, this particular system. Are you able to see that I am breaking this bond? I am breaking this bond and I am getting a positive charge and a negative charge. Are you able to understand that? Whenever you break a bond, you get a positive charge, you get a negative charge, okay? So now if I say, where will the electrophile go and attack? I know that electrophile wants the electron, it will go and attack over here, right? So what I will get, Naharlagan Center, I will get an electrophile here and I am getting a positive charge here now. Is it clear to you now? Naharlagan, the first step is clear or not? Now in the second step, what will happen? Now in the second step, what will happen, Naharlagan? Look at the screen. Look at the screen. You have this hydrogen, na? You were asking me that why the hydrogen is going away. This is the carbon, this is the hydrogen, okay? Now, just break the carbon-hydrogen bond. Let's say just break it for a second. If you break that bond, okay, see, look at this system now here, this particular ring. Here we are getting the H plus and here I am getting a negative charge. This is the negative charge which you are getting, right? You have broken the CH bond, H plus is gone away. We get the negative charge in the ring. So now this negative and this positive will make a bond, okay? So what will happen? These are the double bonds. The plus and minus will make a bond and I having the electrophile here. This is the reason why the H plus go away, because the H plus is going away, leaving behind its electron which can make the pi bond with the positive charge of the ring. Tell me if it is okay with you now, because we people are waiting for you. I hope, Naharlagan, it's clear, okay? And actually, if it is clear, then write it down, okay? No, I will. Okay? Okay, I have one more center from MP. Satna? I'm so sorry if I'm pronouncing it wrong. Okay, so you are a new center, right? Okay, that is nice. Shaili Mishra is the name of the student. Okay, so what we are doing right now here, we are just talking about the organic chemistry and we are talking about the electrophilic aromatic substitutions. Okay, so I hope you people have started this chapter in your schools and you have some idea related to this. Okay, the new center, we have a new center from MP. So if you have any kind of doubt, you people can ask me right now here. Okay, how many students are there? Can you share the number? Just share here the number, and if you feel any kind of query or any doubt, then just write it down here. I'm very much able to read all the comments here, okay? And we are in the mid, okay, only one student is there. So, Shaili, okay, you are there. So, welcome, first of all, okay? And if you find any kind of difficulty or any doubt, we are now here talking about the electrophilic aromatic substitution reaction, okay? Now you are asking me the question typically of that previous one which we have done earlier, but don't worry about that, because if I start explaining your question here now, Nahalagan, then we will totally deviate from the topic, okay? And I don't want this thing. For the timing, just keep this thing in your mind that benzene is the aromatic compound, okay? Benzene is the aromatic compound. We are having an electrophile which is attacking over the aromatic system, okay? Okay. Now we are going to write the mechanism of this nitration here. So Satna center, you can just join from here the nitration part. And again I'm saying if you have any doubt, just write it down here. I am going to write the mechanism here for the nitration. Try to understand it, try to note it down, and then if you have doubt, you can write, okay? And Nahalagan, don't worry, I will send you the notes of that aromaticity topic. But for the time being, please look at the reaction. We are in the mid of the reaction now. Okay. Now, I am just telling you that whenever you have a benzene and you are reacting it with the HNO3, nitric acid and H2SO4, okay, then you get a nitrobenzene as the product. Now, how you are getting the nitrobenzene? I have told you the journal mechanism that whenever we have the electrophile and when that electrophile, goes and attack over the ring, then we get the, the substitution. We, instead of the hydrogen, we get that particular group, okay? Now everyone just look at the screen. I am making the structure of nitric acid here. If we are having a mixture of nitric acid and H2SO4, what will happen? This is the structure of nitric acid, okay? And you know that H2SO4 is more acidic. It's a stronger acid. So H2SO4 will generate the H plus ion. I get the H plus ion. This is from H2SO4. Can you people tell me now what will happen? What will happen? What will the H plus do? Think about it. If we have the H plus ion, what will happen this time? Tell me, just, apply the concept. You know that H plus wants the electron, so where will the H plus go? Definitely it will go towards the oxygen, okay, because oxygen has the lone pair. Look at the screen, everyone. Oxygen has the lone pair, so this H plus will go over here. Now you will ask me the question, ma'am, why it is going to that particular oxygen? Because, it knows that if it goes to that particular oxygen, then it will be able to remove as a water. Yes, Nahalagan. So we are having this H plus here and I am drawing it with the red color. Okay. Now can I make a positive charge here on the water? Why I am making a positive charge here? Because oxygen is making the 3 bonds here. Oxygen has given one lone pair. Okay. This step is clear. New center, is it clear to you? Satna is there. Satna, I am pronouncing it correct? Because I really doubt in my pronunciation. These students, like the earlier students, know very well. knows very well, right? They have very difficult names. Okay. So we have a water here. Okay. And always, fix this in your mind, I'm telling you. Whenever you see any H plus ion and whenever there is some acid or some system like this OH, always remember that H plus goes towards the OH in order to form water. Okay. Now can I remove the water from here? Can I remove the water from here? If I remove the water from here, it means I'm breaking this particular bond. Okay. If I am breaking this bond, everyone, can you tell me which charge will be there on the nitrogen? You are breaking the oxygen-nitrogen bond. Tell me which charge will be present over the nitrogen. Tell me, I'm waiting. Positive charge, obviously, you know that we are breaking the bond such like that these two electrons, let me rub this arrow. I am simply saying that this is the bond here, right? So if we are breaking the bond, okay, if we are breaking the bond, this particular bond, no, Nahalagan, it will be positive. If you are breaking the bond, it means these two electrons are gone towards this oxygen, okay? So that is why you will be forming a complete H2O. At the same time, it will be NO2 plus. Okay, because oxygen was already having the positive, now it will take the negative charge, it will get neutralized, right? So we get the NO2 plus. Just tell me, everyone, understand that we are getting NO2 plus as the electrophile. How we are getting it? NO2 plus as the electrophile, you got it? Just take the time and tell me if you have any doubt. Where the H plus comes from? Zircon, the H plus comes from the strong acid, which is the nitric acid. See, what is the good thing of this reaction, or from where they will ask you the question? Like I'm talking about the conceptual question. Like we are having earlier, if I have written this reaction, concentrated HNO3 and concentrated H2SO4. Now they will say that which acid is behaving as a base here. In the presence of strong acid, zircon, that is the H2SO4, see, nitric acid is accepting the H plus, so it is behaving as a base here, okay? So H2SO4 is acting as a very good acid, it is giving its H plus ion, and those H plus ions are accepted by the nitric acid, okay? So this is the very good thing. Now what will happen is, this H plus ion is accepted by the oxygen and we are getting the water here. Oh, Satna Center, don't worry about that. You know what is happening? You are saying me to recall everything which I have taught. We have just started the very first reaction. Don't worry about that. We have just done one mechanism, okay? And all that particular mechanism is repeating everywhere with whatever I am teaching right now. So, I am just saying that nothing is connected with the earlier part. And definitely what I will do, once your WhatsApp group will be there, okay, once, we will get to know about your coordinators at your center, then I will be sending you the notes. This is what we people used to do. If whatever part of yours is skipped now, then I will send you my notes and then you will be able to, read it, and then you can ask me the doubt on the WhatsApp or on the phone as well, okay? But I'm saying because, it will take a lot of time. I have the 10 centers with me. So you can just start from here and nothing is connected with the previous part. So don't worry for that. If anything will be connected with that, then definitely I myself will, recall it here, okay? So just tell me if this particular reaction of nitration is clear or not. How oxygen got the positive? This is the rule, what is happening. Let me explain this again, okay? Let me explain this again. It's a very simple thing, everyone. I have made a structure of the nitric acid. This is the nitric acid. And in the presence of more stronger sulfuric acid, okay, this is the H2SO4 which is giving the H plus ions, which is continuously giving the H plus ions because it is acting as a acid. It's a strong acid. And nitric acid, although it's an acid also, but in the presence of H2SO4, it is acting as a base. Now, what is the work of a base? The base accepts the H plus ion. This is what I'm saying. So, Naharlagan, when we know that the valency of oxygen is 2, now oxygen makes the 2 bond. Always remember this thing. When oxygen accepts this H plus ion, okay, then what will happen now? We are having O, nitrogen, this is double bond, this is oxygen. Yes, H2SO4 is dissolving, obviously, okay, that is why it is dissociating into ions zircon center. Now this H plus I am attaching it with here, okay. Whenever oxygen makes 3 bond, it means oxygen has given its 1 lone pair, now only 1 lone pair is present. Initially there were 2 lone pairs on the oxygen, but due to the H plus ion, we have a bond formation, so 1 lone pair is gone in the bond, okay. That is why we used to draw the positive charge here on the oxygen. Whenever oxygen has 3 bonds, we used to draw 1 positive charge. It's a similar thing, You people are aware about the term ammonium ion. Ammonia is NH3. When NH3 accept 1 H plus, you make it NH4 plus. Are you getting me? Naharlagan Center. Okay. Now what I'm trying to do, everyone now just look at the screen. Now this is the bond which is formed of 2 electrons. Now I'm saying these 2 electrons are again taken by the oxygen as well. Okay. So what will I get? I will get my H2O back. 1 lone pair was there and now I get the another lone pair as well. This is the H2O neutral and the positive charge will be there on the nitrogen. So I get the NO2 plus also. I hope now it's clear. Oh Iswal, why you people are making it confusing? Okay, because I was just trying to explain it in much detail. If you people are those who are getting confused, nothing to worry. Just keep one thing in the mind that, in this particular reaction, nobody is going to ask you these mechanism I was telling you. Okay, I was telling you. As well, what is the main concern of ours is, we have a concentrated H2SO4 and whenever we have a concentrated HNO3, always remember that we will get a nitro group, okay. Whatever group I am getting on the benzene, that particular group will be my electrophile. So what is the electrophile in this case? That is NO2 plus, that's it. Nothing is there. Only this thing you have to keep in the mind. Whatever question you will see, like the question will be, they won't ask you to write each step in the detail. I was telling you, okay. But this is the question they will ask, that just by looking at H2SO4 and HNO3, you have to take care that you have to perform nitration here and you have to make a nitrobenzene as the product. Is this okay, Azwal? Just tell me if it is okay. St. Paul, zircon. Is it clear? Halogenation is clear? Yes, Naharlagan. Oxygen has given the 2 electrons to the hydrogen. Okay. Satna Center, this reaction is clear to you? You can also write. Whenever I try to go into much detail, something happened. Okay, no problem. So we are done with the nitration. I'm talking about the third reaction here, okay? I'm talking about the third reaction. This says sulfonation. Now see, you people will tell me the answer. If I want the sulfonation, what will happen now? I will have a benzene. Can you people tell me that which group will be there on the benzene? Which group will be there on the benzene? Azwal Center, I will come to the nitration again, okay? For the timing, let's leave it. Let's come to the sulfonation, then we'll come to the nitration, okay? Let's take a break from the nitration, okay? Because if I'll try to write one more time, then you people will get understand and the other center will get confused and they will write, okay? Don't worry, we'll come to the nitration again. So which group will be there? Obviously, we are talking about sulfonation. Have you ever heard about sulfonic acid? Sulfonic acid. So in this particular reaction here, the reaction is only with the concentrated H2SO4. So H2SO4, have a sulfonic group here. So we get SO3H. This is the reaction. And we will be, now let's do one thing. The very important mechanism we'll do right now, okay? The mechanism which are actually not important, we will not write it. But yes, nitration I will tell you again in the end of the class. This is clear? A benzene is there, concentrated H2SO4 is there. So always remember, now if H2SO4 is there, you have to do sulfonation. When H2SO4 and nitric acid is there, then we used to perform the nitration, right? We have done 3 reactions, everyone. Number 1 is the halogenation. Number 2 is the nitration. Then number 3 is the sulfonation. This is okay? And what the name of this compound? This is nothing but a sulfonic acid. Okay? Now coming to the number 4 reaction. This is again a very interesting and important reaction. This is known as Friedel-Crafts. This is something known as a Friedel-Crafts reactions. Now we have 2 types here. One is the Friedel-Crafts alkylation. Alkylation, everyone. The term name is alkylation. Can you people tell me what do you understand by the term alkylation? How many of you understand the term alkylation? Yes, exactly, St. Paul, very good. Putting one of the alkyl group, yes, exactly, Sircon, this is correct. As well, any idea? What is an alkyl group? See, methyl, ethyl, propyl, all these are the alkyl groups. Whenever you are adding this type of group on the benzene, okay, that is actually the alkylation. These are the journal terminologies. If I am saying halogenation, it means it's the addition of halogen. If I am saying hydration, what does that mean? What is hydration? Adding of which group is hydration? Tell me quickly. Addition of water, obviously. It's the hydration. You are giving water. At the same time, you use the word hydrolysis also, okay? And if I am saying alkylation, it means the addition of alkyl group. If I am saying carboxylation, what does that mean? Tell me. If I am saying that we are performing carboxylation here, any idea, anyone? What is carboxylation? It means the addition of the carboxylic group. You understand that carboxylic group is something like COH. You have heard about the carboxylic acids, na? So addition of carboxylic group is carboxylation. Now what if I say dehalogenation? What does the dehalogenation mean? Do you know that? Anyone having any idea? Shillong, any idea? The students from the Shillong Center. Shillong, I guess your chat system is not working today. Is that so? Anyone having any idea regarding the dehalogenation? It's the removal of the halogen. Okay? Yes, whenever you have a word D there, it's the removal of the halogen, okay? And what if I am saying dehydration? If I am saying dehydration, see, because these days it's very hot in Delhi, okay? Whenever I used to come for your class, very bright sunny days there, so much, the temperature here in Delhi is near about 40 degrees Celsius. So we used to get dehydrate, okay? So dehydration is removal of water, okay? It's a very general terminology. So this is what I'm saying. Obviously, it's the removal of the water molecule. So I'm saying whenever you see a term D there, like halogenation and dehalogenation. So dehalogenation is removal. If I am saying decarboxylation, excuse me, if I am saying decarboxylation, then it is the removal of the carboxylic group, okay? Because we will be, taking all these terms into the consideration while doing the other reaction mechanism. Let's come back to the alkylation part. Everyone just look at the screen. The journal reaction is, this is the benzene, and what will be written on the arrow? Like they will write like CH3Cl. Like I have taken the example of methyl. This is in the presence of AlCl3. Now what will happen? First of all, I am writing the journal mechanism, journal reaction here. Then we will talk about the mechanism, right? So what I will be getting? I will get a methyl benzene. I get a methyl group. I get an alkyl group over the benzene. So this is what? This is the alkylation. Everyone, now look at the screen. I am writing the mechanism for this. I am writing the mechanism for this. See, we have a CH3, we have a chlorine, okay? We have a CH3, we have a Cl. Now, can you people tell me what will happen if I put the AlCl3 here? Can you people tell me what will happen? I have an alkyl halide this time. This is methyl chloride. So methyl chloride is present in the presence of AlCl3. What will happen? Aswal center, what will happen now? Tell me. Yes, this is chloromethane, right? We can call it as chloromethane. Naharlagan, it's a common name then, okay? Methyl chloride is the IUPAC considered name. What will it form? Tell me quickly. We have already done a reaction with Cl2 in the presence of AlCl3. Yes, very good, Aswal. So you will get AlCl4 negative at the same time. Which is the species with the positive charge? See everyone, can I write it like this? CH3, Cl and AlCl3. Something like this I will get? Yes. So it means this is something negative. Delta negative, this is something delta positive. Here I will get CH3 plus. And here I will get AlCl4 minus, okay? Now what is my electrophile here? Tell me. What is my electrophile here? Yes, see if I am saying where is my electrophile here, so you will say ma'am it's the CH3 plus, okay? So can I write the next step, the attack of electrophile on the benzene? Obviously CH3, okay? So I hope you people got the concept now. What we will do, this is the CH3 plus. Now, you can write all of these steps again, okay? But I am not writing here, I am directly writing the product. So, what will I get? I will get here CH3, okay? Do you know the name of this compound which I got in the product? What will you call when you get a methyl on the benzene? What is the name? Methyl benzene, yes, we can call it methyl benzene, but obviously methyl benzene is the, you already know it. Any other name, Nahalagan? A common name is there, you know. A common name is there. Very good. Santna Center, okay. The spellings are, so long your chat system is working. Very good. Toluene, yes, it's the, sometimes people used to call it as toluene. We can call it as, this is toluene. Okay. Common names are very important. Some of the common names are actually very important, so just take care of that. Okay. So this is the one question. Try one more example. You people just try. Write down the product and tell me the answer quickly. Ethyl benzene is the product which the Sercon center got. Let's see what the other centers are getting. What is the answer? St. Paul, what is the answer? Senapati Center, CC Pur, New Center. Okay, so you people are getting the ethyl benzene right? Ethyl attached to the benzene, obviously. So can I make it like simply I'll remove the Cl, I'll get the positive charge, you know, and I'm attacking it on the benzene. I am not writing the mechanism again. I am simply writing the product, which is CH2, CH3. So we used to call it as, this is ethyl benzene. This is the important thing, okay? Here we are getting a carbocation, okay? What we are getting? We are getting a carbocation. This is what? This is a carbocation. You remember, I guess we have done the rearrangement in the carbocation. How many people are aware about the rearrangement? Although its common name is not that important, but the common name is phenyl. This is something like phenyl. Okay? No need to write phenyl because this is, no need to remember it, okay? Nobody going to ask you, but the name is the phenyl. Now again, we will only learn the common names which are important. Although there are certain other common names also, but these are actually not important, okay? The only thing is like whenever a methyl is attached on the benzene, whenever let's say OH is attached on the benzene, that is a phenol, like methoxy group is attached, which is known as anisole. So these types of systems are important, okay? Nobody is going to ask you the common name of this compound, so no worries for that. Okay, just tell me one thing. I am saying that in this particular reaction, I get a carbocation. Do you people understand the rearrangement of the carbocation? How many of you understand that? I guess when we were talking about the GOC, the topic of the 11th class, we have done the carbocation rearrangement. I'm waiting. Just tell me, then I will let you know. How many of you understand the term carbocation? Sercon center. Smileys, huh? We have done it. St. Paul, don't you think? Shillong, you know the carbocation rearrangement, right? I can rely on you people. Shillong, tell me. Rearrangement of carbocation, have we done it? Say, Shillong Center always say the truth. I know that. See, I know that. So good people they are. Blessings to them. See, they are writing. They know what is rearrangement of carbocation. Those who don't know, look at the screen. Don't worry. Blessings to you people also. So just look at the screen. I am saying, see, okay, just tell me one thing, okay? That this is like this time in this particular question above, I got CH3, CH2 plus, okay? This is simply a 1 degree carbocation, okay? Let's say, what if you are getting this type of, carbocation, CH3, CH2 and CH2 plus, okay? Now, there are the chances of rearrangement in the second number of compound, okay? This is initially, this is what happens in Senapati center. Okay, just try to understand this carbocation and whatever your confusion is, write it down, okay? Okay, just look at the screen first of all. I am saying, let's say this is the compound given to me, okay? This is the system given to me. This is a 1 degree carbocation, you understand that? Because this positive charge carbon, this particular carbon is attached with the 1 carbon only. This is a 1 degree carbocation, okay? Now what happened, why I am saying the word rearrangement? What happened is that every system wants to become more stable. And we know that 3 degree carbocation is the most stable, then 2 degree carbocation and then 1 degree carbocation. Now see what will happen if I just make the structure like this. Senapati center, look at the screen, okay? This is, I am making the same structure, like we have a CH3, this is the carbon, hydrogen, this is again CH2 and this is plus. I am saying, let's say, we are swapping the position of this hydrogen and the positive charge, okay? I am swapping the position. It's known as a hydride shift. I am swapping the position of the hydrogen and the positive charge. What will happen this time? See what will happen. We have a CH3 now. Now this carbon, this hydrogen, this was the CH2. Now what will happen? The positive charge goes on this carbon and a hydrogen is there. Are you people getting it? Now can you tell me which degree carbocation I got? Which degree of carbocation I got? This was the 1 degree. What is the degree of this one which I have drawn in the blue color? Tell me. Senapati center, which is the degree there? It's the 2 degree, right? Nahalagan, you are correct. What's the degree here? It is a 2 degree carbocation. Everybody got it? This is a 2 degree. Because why this is 2 degree? Because this center carbon which is having the positive charge is attached with the 2 carbons there. Okay? It is attached with the 2 carbons there. Okay? So this is what I am saying, that whenever there is the option that you can have the hydride shift, then you will do it, okay? And you will make a more stable carbocation. This is more stable. Why we are shifting? Because we are making a more stable carbocation. Just tell me, Senapati center, if this is clear to you. Hydride shift is clear to everyone. New center, Satna center, you can also let me know. So this is clear, right? Okay? Just note it down because this is important. Done, everyone? Now look at this screen. You know, you people were confused here, Senapati center. This was so simple question. You understood this part, Senapati? You understood this part? We have a CH3Cl. Just remove the Cl. We have just removed this chlorine. Just remove it. You are just breaking this bond. You get a CH3 plus here. You get a Cl minus here. Once you get the electrophile, just paste the electrophile on the benzene ring here. This is the only thing. This is the very simple mechanism. You people are just, I know that because you people are reading it for the first time. Obviously, there might be the confusion. Is it clear now? Senapati Center? Tell me whatever your doubt is, okay? I'll make it more clear. Now, let's do one more example, everyone. Keep the carbocation rearrangement in your mind, okay? Keep the carbocation rearrangement in your mind and then just write the question and write the answer. Tell me the product of this compound. The same way you will approach, okay? Remove the Cl, make the positive charge. If there is any option, then have the rearrangement and then make the product. And you will tell me the answer of this question. You can write the name. What you are getting? Propane benzene. I guess Sircon and Azwal Center, you have done that mistake. You people have either removed the Cl. You got this type of carbocation, right? You got this type of carbocation and you have just, just paste it on the benzene. Think about it. Once you are getting the carbocation, is there any chance of rearrangement? If there is any chance, just do the rearrangement and then make the product, right? Now think about it and now tell me the answer. Yes, very good, Shillong. This is the correct answer. Shillong, do you know any common name of this particular compound which you have written? Your answer is absolutely correct. But I'm saying, do you know any common name of this compound? Everyone look at the screen. I am doing the question, okay? Now what you people have done, look at the screen. You people have taken CH3, CH2, CH2, this is the Cl. You are making a bond with AlCl3, which is absolutely correct. Dimethyl methane benzene. Okay. Yes, as well. This is the correct answer. Very good. See now, what you have done, like if this is the chlorine and this is the AlCl3, what will you do now? You can make it like CH3. I'm so sorry, CH2 is there. Then we have a CH2, then we have a CH2 plus, okay? And where we will have a AlCl4 negative. AlCl4 negative. Now, many of you, what you have done, many of you have done like this. Those who have writing the answer propyl benzene, like Sircon Center, just look at the screen. Now, I hope you have done this thing. That we get the electrophile. Okay, this is the positive charge. It goes and attack, and then you are making this as the product. This you people have done. But I am saying, why are you just having that propyl on the benzene? Don't you think this is the same thing which we have done above here? This is the same compound, this one. Okay? So I am saying, once I got this carbocation here, just look at this carbocation very carefully. This is a 1 degree carbocation, okay? And there are the chances where we can have a more stable carbocation than this one. Again, look at the screen. CH3, CH. I'm opening the bonds, okay? That's why it will be more easy to relate. One hydrogen above, one hydrogen below. Here I will have a CH2 and here is the positive charge. This is a 1 degree. Can I swap the position? Okay. These are the chances. We can do that, okay? So I am rearranging it. Rearrangement. This is known as rearrangement of what? Of carbocation. Swap the position of hydrogen and the positive charge. By doing this, what will I get? I will get a more stable carbocation. This is the CH2. By swapping these two positions, I will get a positive here, I will get a hydrogen here. Now how it will look like, everyone? How it will look like? It will look like a CH3, CH having a positive charge and a CH3. Now this particular compound will go and attack over the benzene. So we will have a benzene here, okay? And I can have CH3, CH plus and CH3. Now this particular group will go and attack, and what products here I am getting? I am getting this time. See, I am getting a CH, this is a CH3 and this is a CH3. Some people used to call it as a isopropyl. This is nothing but an iso group. Instead of the propyl benzene, I get a isopropyl benzene. Okay? Any doubt in this? Satna Center, any doubt you have? We have done the rearrangement, and after rearranging the carbocation, I have, shown the attack and then make the product. So always, think like that. Although in the NCERT or in your school exam, they won't ask you this question, but only one example we have done, okay? That whenever we have the chance, because if you are dealing with methyl chloride or this thing, so nothing will be there. This is a common name, Naharlagan Center. Whenever you have, you don't have a straight chain, okay, of propyl, instead you are having one group attached, okay, in this form. This is known as iso. This is the common name, nomenclature part. Okay, so we have written isopropyl here. And this particular compound has one more common name. This is known as cumene. I will explain iso and neo. Don't worry. This is also known as cumene, okay? When you have a isopropyl benzene, this is also known as a cumene. Is it clear? So I guess now you people will able to solve all of the questions related to the Friedel-Crafts alkylation. Again, have a look, everyone. Have a look here. We are having a CH3Cl. Just remove the Cl because there are no chances of rearrangement, right? That is why we haven't shown rearrangement. I got the methyl plus. This is my electrophile. Attack on the benzene. Then you get a toluene. Same is the ethyl chloride. Remove the Cl, no chances of rearrangement, you will get ethyl benzene. One case of rearrangement we have done in propyl, that in the propyl instead of this. Although, this will be the product, you cannot say this is the major one. Yes, Naharlagan, you are correct. This is because the CH is attached with 2 CH3. This is known as iso group, okay? So this CH is attached with 2 methyl groups. That is why it is iso. I will explain iso and neo just after one more reaction, okay? Satna Center, is it clear to you? She is the new member here, na? So we have to take care for her. Good. If you find any kind of, difficulty, you can just write it down. And I guess Satna Center, you are from MP, so you very well understand Hindi. You understand Hindi, na? Because here we have a bunch of centers, those who don't understand Hindi. Hindi is like some, other world language for them. They don't understand Hindi. Okay, that is nice. So we have done the reactions related to the Friedel-Crafts alkylation like we have just done. So one more reaction related to that. What is the number? Number 5. Okay, that's the second part. Everyone just look at the screen. As well, I know that तुम्हें आता है, ठीक है? Okay. Friedel-Crafts alkylation we have done. I am writing now Friedel-Crafts acylation, second part. Acylation. Now we are, the name itself is saying that this time you are talking about acyl group, okay? You people understand what is the acyl group? Let me give you an example. Any RC double bond O group, this is an acyl group. You know that you used to call it as RC double bond O chlorine. This is an acyl chloride actually, okay? So RC double bond O group is known as an acyl group, okay? So this is the case. Now I am writing the direct reaction first of all, then we'll talk about the mechanism. We have a benzene here, okay, and we have like CH3, or I can write R. In the terms of R we can write, let's say I have RC double bond O Cl, okay, this is an acyl chloride. Again I'm writing the word acyl, this is chloride. So once you get the AlCl3, what will you form? This time, whole of the acyl group will be there on the benzene, like C double bond O R, okay? So you will get this as the product. Just write it down, then we'll write the mechanism. Okay, can you people tell me which is the electrophile here now? Which group will be the electrophile? Tell me. Which group is the electrophile here? Tell me. See, what group is there on the benzene? The group which is there on the benzene will be acting your electrophile. Yes, acyl group will be the electrophile, obviously. Now look at the screen, what will happen now? See everyone, just look at the screen. We are having R, C double bond O, and this is the Cl. Can you tell me what will happen? We have a AlCl3 again. So don't you think we will be getting RCO, this bond will go away, having some delta negative charge, this will have some delta positive charge, it will be having bonding with AlCl3. In the same way, what you will get? You will get RC double bond O, this is the plus, and here you will get AlCl4 negative. Just tell me if this thing is clear to everyone or not. This acyl group of mine is the electrophile. And what is the good thing here, that there will be no rearrangement in acyl, okay? Like we were doing the rearrangement in alkylation, na? Here is the no rearrangement. Why, you know that? See, because this carbocation is already quite stable, because in its, the neighborhood there is the lone pair. I used to say this, line many times earlier. Whenever a carbocation have the lone pair in its neighborhood, okay, then it becomes very happy because it has the chances to have some kind of resonance there, okay? So it's already stable, no need to have any kind of rearrangement. Directly this group will go over the benzene and attack. Just tell me if this electrophile is clear. Senapati Center, is it clear to you? CC Pur, you can also write. This chat system is for you people also. And we will be so happy to have your answers here on the screen. St. Paul, any doubt? Shillong, any doubt? Nahalagan, any doubt? I guess today actually the whole of the centers came here. But yes, I guess 0 center is not there. Okay, so we get the electrophile. This is the acyl. Okay, so if I just, write the reaction of this acyl group with the benzene. So RC double bond O, here is the positive charge. Just simply it will go and attack on the benzene. What will I get? I'm not writing the complete mechanism again, okay? I'm directly making the product here. So you people can also make it. So acylation is clear to everyone? Senapati Center, Satna Center, New Center. ठीक है क्या? Is it okay? Okay. When I am teaching in flow, then the things automatically flows out. Is it clear? Okay, so we are just done with the acylation also, and let's write one example. You people will make the product. This is the benzene. Let's say we have CH3, C double bond O, Cl in the presence of AlCl3. Write down the product. Write down the answer quickly. Will Cl be there in the product, zircon center? Acyl benzene. Oh, very nice. Iswal, your answer is correct, although the common name is not correct. But yes. Which functional group you are getting in the product? I'm asking you which functional group you are getting in the product. Ketones, very good, very nice, yes. CH3CO. Cl will not be there, na? Zircon center. See, you will be removing this Cl, you will get the positive charge here, it will go and attack. And what will be, we will be getting? We will get C double bond O, CH3. This is a very similar question. Instead of the R, this time I have given you the methyl. So you can say this is acyl benzene, this is also correct. This is what? This is ketone. You are getting ketone here, okay? If I tell you the common name, this is something which is acetophenone. This is acetophenone. This type of name are there in the NCERT. That is why we are doing it. Everybody understood the concept? Serkan, are you clear that we will not be writing the Cl in the product? Okay, obviously there won't be any Cl. We will be having CH3 C double bond O. You will attack it on the benzene, you will get the product, right? Let's do one more question. I am writing here pH. You understand what is pH now? It's phenyl. Write down the product for this one. You understand what is pH? It means you are having the benzene ring there, okay? Write down the answer. Oh, silly mistake. Serkan Center, it's okay, it's alright. You are free to do the silly mistakes in the classes, but obviously you are not allowed to do the silly mistake in the exams. But you people used to do the reverse thing, na? Many a times we have seen, the student, those who used to do the correct questions in the class, when they are writing the exam, then they do actually the silly mistakes there. What will be the product here? Anybody knows the common name of the compound? Shillong, any idea? We know the answer, but we don't know the common name. And see, this actually happens in the exam. See, organic is easy. People can do the mechanism, can write the reaction very easily. But where they actually get stuck, like this question I can ask in the NEET or in the ITJ exam, and I can ask you, that what will be the common name. In the option, I will give you the 4 common names, and then I will ask you that question. Then you will get the product, but you don't know the common name, so okay, no problem. What is the IUPAC name for acetophenone? Nahalagan, actually you know that acetophenone is itself the IUPAC name, okay? Like we used to say phenol, we used to say toluene. These are the common names, but they are the IUPAC considered also, okay? Same is the case with the acetophenone. If you just check now, acetophenone is itself the IUPAC name, okay? Now look at here. Let's make the compound. This is something like, I got a benzene, I will get C double bond O, and I will get a phenyl here. Or if I expand the structure, it's something look like this one. Again a benzene, C double bond O, and here also I get a benzene. See, the earlier one you say acid. Acid is, that it's a common name for this particular group. Acetate you used to call as, okay? So acid is whatever CH3, C double bond O is there. Now when we have a benzene instead of the methyl, now here I can write the word which is benzophenone. Okay, so this is the common name. Now keep these 2 common names in your mind, and I've told you earlier also, just make a list. Whenever you are writing, like in the class, or whenever you are doing any kind of self-study, wherever you find any common name, just make a list at the end of your chemistry notebook, because it would be helpful for you, okay, in devising the common names. So this is benzophenone. When you have methyl, you call it as acetophenone. When you have benzene, then you call it as benzophenone. Nahalagan, this is also the common name, like the IUPAC considered name for this particular compound, okay? Done, everyone? Why phenone word? Listen to me. These are the ketones. Ketone, when you see the suffix of the ketone, you say propanone. You used to say like, I should say butanone, pentanone. So on is used for ketones. On is used, okay? Then that is why we are having phenone here in the last. And here also it's acetophenone, or we can have the benzophenone, right? Is it clear to you, Narlagan Center, now? Is all what happened. We still have the time, okay? Don't feel so happy. We still have the time. We can do one more topic here. Is it okay? See, Nahalagan is asking me the question that why not benzone is there. Nahalagan, till far we don't have benzone. See, might be you people will be discovering some of the compound, okay? And like when you do some in the future higher studies, then you can invent some of the compound, okay? So there is still far, we don't say it as a benzone, it's just a common name. We used to call it as the acetophenone and the benzophenone, right? And no, benzone is not there, no. Okay, so let's revise all of the 5 reactions we have covered in this particular case. I am writing the reactions here below, okay? Just have a look. See, the common mechanism is always there for the electrophilic substitution reaction. So if you see simply a benzene is there, and if you are reacting with any of the halogen in the presence of the catalyst, which is the Lewis acid here, you will get what you will get. You will get a chlorine there, okay? In the same way, let me write it like this. This is the first, just let's change it. I'm saying here it was the Cl2 and AlCl3. Like here, if I have concentrated HNO3 and H2SO4, what product I will be getting? Or if I have a concentrated H2SO4, or if I have, I'm writing here, Rx in the presence of AlCl3, and we can have one more example. Okay, we can have one more example here of RC double bond OX in the presence of AlCl3. So these all of the 5 examples we have done. You already know the products. So in this case, we will be getting a nitrobenzene. In this case, we will get SO3H. This is sulfonic acid. And the process is same everywhere in all of the 5 reactions. The only thing which is different is the generation of electrophile. Once you get the electrophile, in the same way it will go and attack over the benzene ring, okay? Here what I will get a R group, and in the last, I am writing the last one here. In the last one, I will get C double bond O and R. Now quickly have a look and just tell me if there is any doubt. Regarding that nitro part, no need to create all that mess, because nobody is going to ask you. I was only telling you that how we are getting NO2 plus, okay? That was the case. Just tell me if it is okay. Then we can, if you want, I can write that NO2 part again, or I can explain you with the iso and neo, because some of the students were asking me for that. Just tell me if you have any doubt till far. Rx signifies, Naharlagan, R is the alkyl group. R is the general notation, like I can have CH3Cl or CH3CH2Cl. So all of these groups are known as R, and X is the halide here, okay? So R is any alkyl group and X is the halide. Ethyl, methyl, propyl, pentyl, and up to so on, all comes under the category of R. R is the general notation. And for the halogens, we used to donate it with the X. Tell me if it is okay or not. Everyone, I'm waiting. And if you just check the first chapter of the NCERT, that is the haloalkanes and haloarenes, I will try to share that particular portion of NCERT in all of the WhatsApp group, right? So, and I will mark the topic there, okay? So it's very important to read once the reaction from there. Although all of this particular topic is not completed yet, but at least you can have a look from there. Just tell me if it is okay. Nahalagan, Aizwal Center, St. Paul, Satna Center, Senapati Center, and Shillong. Any doubt till far? Okay. Okay, like some of the students were asking me for the ISO and NEO. Okay, this is something a nomenclature part. Now, what is NEO and what is ISO? Let me tell you. Everyone? Yes, nitrogen part, I'll come to that also. I'll come to that also. Okay, let me write first of all nitrogen, that part, because that is more important and related. ISO and NEO, if we'll still not get time because there is a class about to start. So what we can do, I can share in the group that thing, okay? Sercon Center, the ISO NEO, I can share about that thing in the group also. Look at the screen. What was happening? Like when we have the mixture of HNO3 and H2SO4, although both are acid, but in the presence of H2SO4, this act as a base and this act as an acid. This is what I was saying, okay? Now what is happening here? We are having this is the structure of HNO3, everyone. This is the structure of HNO3. Now, I get a lot of H plus from this one. A lot of H plus. This is a source of H plus ion because it's a very good acid. It's a source of H plus ion, okay. Now, H2SO4 is producing a lot of H plus ion. So, what will happen? This H plus will go and attack over the lone pair of this oxygen, okay. It will go and attack over here. What will happen now? See, I am again drawing. Just keep it very simple. Nothing is there. Let's keep it very simple. Okay. One lone pair is already there. One is gone in the bond formation, right? I get a hydrogen here. Aizwal, any doubt till far? Anyone having any doubt till far? Just tell me. Aizwal, quickly reply. I have make a bond with the hydrogen here. Anyone having any doubt till far? Just write down quickly. And just keep one thing in the mind, those who give the electrons are very good people, okay? I have tell you this thing earlier also. Those species which used to give the electrons, okay, like they are in the habit of giving, they are very good people, okay? They always give. So they have the positive charge. Those are the positive people, okay? Those people, those who used to take the things from the other, they used to grab the things, they used to, gain the things. Those are the negative kind of people, okay? They have the negative charge over itself. Why H2SO4 is giving electron? I am saying that H2SO4 is giving H plus ion, not the electron Aizwal center. H plus ion, like the maximum of the H plus ion is coming from H2SO4. It gives H plus. This is the work of acid. Acid, which is a very good acid, those used to give a lot of H plus ions, okay? So we are just taking the H plus ion, okay, and making a bond here, okay? Is it clear now, Aizwal? I am saying this H plus ion comes from the acetic acid and that is why it is making a bond, okay? Now in the next step, what you have to do, see, oxygen has given its lone pair. Those who used to give the lone pair, I just tell you that what charge they bear. They have a positive charge over themselves, okay? Now tell me this is clear as well. Oxygen usually make the two bonds, na? If some extra help oxygen is giving to the hydrogen, then it will bear the positive charge over itself because oxygen is giving its electron to the H plus ion. Clear? How ONH are forming covalent bond when only oxygen is giving its electron? Oh my God. Nahalagan center. Oxygen has the two electrons. H plus do not have any electron. So one which is empty, it doesn't have the electron. But oxygen do have the electron, then can't they make a bond? It's a very simple thing, okay? One species having the electron, a bond is formed by two electrons, right? If one is having the 2 electrons and the other one is saying empty, I don't have electron, H plus doesn't have any electron. So oxygen is giving both of its electron and then forming the bond, okay? Now everyone look at the screen, what will happen? I am breaking this bond now, okay? I am breaking this bond. How I am breaking this bond? Like in such a way that oxygen being more electronegative will take both of these 2 electrons. Look at the screen. These are the 2 electrons with the sky blue color. Both of these 2 electrons will be taken by the oxygen because it is more electronegative, right? So what will you see here? This is hydrogen, this is oxygen, this is already hydrogen. I have broken the bond of oxygen and nitrogen, okay? Now here is the nitrogen, this is double bond, this is the case here. Already oxygen was having one lone pair. Once this bond is broken, both of these 2 electrons are taken by the oxygen here, okay? That is why you are forming the water here, H2O, and this NO2 is having the positive charge. This was the case. Now just have a look, and you can show the positive here, no problem in this case. I am saying that positive will get removed in the last step, okay? Why we are removing the positive from the oxygen? Because now the oxygen is happy. It is getting that 2 electrons back. It is now neutral. It is the water now. This is the case. Yes, Naharlagan Center. It is the heterolytic cleavage, okay? It's the heterolytic cleavage. Although I am telling you again, nobody is going to ask you so much detail, okay? This is for our understanding, that how we get to know that, how the NO2 plus is forming, why we are taking H2SO4 and HNO3. This is the reason for that, okay? That H2SO4 will give the H plus ion, and it will help us in, in the creation of this nitronium ion, okay? Or you can just call it as electrophile. H2SO4 only helps in the creation of NO2 plus. Now, Aizwal, is it clear? Quickly tell me if it is clear. Anybody having doubt in this nitration? If you are still getting it stuck into it, then still almost is there. Okay, no problem. I hope you people have written it. Again, once you go home, just look at the mechanism again. And still, if you find any kind of difficulty, just post it into the group. I will explain there again, okay? Or I will share some notes over there. Is it okay? So we have completed one complete mechanism. Or Aizwal Center, nobody is going to ask you that particular thing. This is for our understanding. The important thing is these 5 reactions, okay? Why only this one is very hard to understand? Oh, no problem, Aizwal. Because you are just studying it for the first time, right? That is why it is happening. Don't worry. It's very easy. It is actually very easy. But, okay, if you are getting stuck, you can also leave it, okay? The formation of NO2 plus, you can leave it. No problem is there, because nobody is going to ask you that question. The important thing is that whenever these type of reagents are given, then you are able to write the product or not. This is important. Okay? Is it clear? Shillong is ready to go home. They are just sitting, pack their bags. Okay, so that is it for today, okay? And this is my request. Please revise today's lecture. And in the next class, we will try to learn SN1 and SN2. It's this nucleophilic substitution reaction, okay? So this is the next mechanism. We'll try to do that. We will do some more examples related to this one, and then we'll start the new mechanism. If anybody having any kind of doubt, please post them in the group. All these reactions are very, very important, and because this is actually from the 12th class, okay? So that is it for today. Thank you so much. See you in the next class. Bye-bye.